So when we're writing our trig ratios, we need to know, first of all, what trig ratio we're dealing with. So again, remember, we're using SO, CA, and TOA, okay? And the way I like to think of it with SOHCAHTOA is when I have my sine, okay? So sine of my angle is going to equal opposite over hypotenuse. So I'll write it as SO, and then cosine of theta equals adjacent over hypotenuse, so it's CA, and then I have tangent of theta equals opposite over adjacent, so we have TOA. So I can use that to help me out. First of all, remember, we've got to be able to label all these, so I'm going to go on ahead and kind of cheat a little bit. I'm just going to label all of my hypotenuse for everything. This is kind of how I work the system. Okay. You do what works for you, but I like knowing where my hypotenuse is for all these. And then I can go through and label my opposite. And notice that I'm just using the abbreviations O and H. I will use A when I get there. But I'm just doing all of my opposites right now. Not a whole lot of thought here, just tracing that angle theta, drawing a line across, okay? And then what that allows me to do is all of my adjacents are going to be the side that's left, okay? Notice that it is always right next to that angle. Nope, right here. And we're not cheating, but all of these triangles are essentially the same. So when I'm going through this, I just really need to identify what am I needing. So this first one, top left, sine of A, I need my opposite and my hypotenuse. I don't care about what my adjacent side is. So for this first one, I could care less what that is. I just need my opposite, 5, over my hypotenuse, 13. Cosine, I don't care what my opposite is. I just need my adjacent, which is 12, over hypotenuse, which is 13. My tangent, I don't care about my hypotenuse. I'm just going to put my opposite, 5, over my adjacent, 12. And something that you'll find, opposite, no matter what, is always going to go on top. In the case of sine, in the case of tangent, opposite always goes on top. My hypotenuse always goes on bottom when I use it. And then adjacent is dependent upon if I'm dealing with sine or cosine, whether it's on top or bottom. So again, sine, opposite over hypotenuse, so I don't care about adjacent, 12 over 13 here. My cosine, I don't care about my opposite. It's going to be my adjacent, 5, over my hypotenuse, 13. And then my tangent, I don't care about my hypotenuse, is going to be opposite over adjacent. And notice these two triangles are the same triangles, but we put our angles in different spots, okay? And we can see a relationship between, they're basically inverses of each other. We're just flipping them, okay? Here we just flipped our numerator and denominator, and then we just flipped our ratios between sine and cosine. So there should be some similarity, some familiarity between those when you're dealing with the same triangle. but it does kind of look like a bunch of craziness if you let it. So again, sine, so I don't care about my adjacent. It's going to be opposite 45 over my hypotenuse 53. Cosine is going to be adjacent over hypotenuse 53. And then tangent is going to be opposite 45 over adjacent 28. And then over here on the far right, sine is going to be opposite 28 over hypotenuse 53. Cosine is going to be adjacent 45 over hypotenuse 53. And then tangent is going to be opposite 28 over adjacent 45. And that is how we solve SOHCAHTOA questions.